This is the surface integral. What is surface integral? Surface integral of a vector point function f over a closed surface, as this is the closed surface, is defined as the integral of normal component of f along taken over the surface S. This is our surface integral. How it is? First of all, let us consider a surface S. This is the surface S, and we are having vector point function f that is acting upon this surface at point P. And let us consider the small element delta S over the point P, and here we are having the unit normal vector acting normal outwards toward this point, as we are having the direction outward, so it is acting at point P but its direction is outward, and it is at the angle theta from the vector point function f, as it is the normal vector of the f. Now, so as we are having the delta small element for the surface S, and n cap is the unit normal vector, and normal component f we are having f cos theta or f vector dot n cap. Now, surface integral we are having double integral over the surface S, f vector dot n cap ds. Now, how we will solve this and why we have taken the double integral? Because as this is the surface S, but this surface is on 3D dimension, and in 3D dimension we are having x, y and z. But at one point we will consider two planes, either xy, yz or xz plane, and these planes are like this. We are having yz plane and it is perpendicular to the x, or x is perpendicular to the yz plane. Now let us see. We are having, if we are having f vector is equals to f1 I cap plus f2 j cap plus f3 k cap, and ds vector we are having dy dz I cap. Why we are having dy dz I cap, not dx? Because let us see here, we are having yz plane, and our I cap, we know I cap is the direction of x axis. This is the direction of x axis, and this is perpendicular to the which plane? This x is perpendicular to which plane? yz. So as we are taking I cap, so it will be perpendicular to yz plane. So we write here dy dz I cap, not dx, because we are having the direction of x perpendicular to yz plane. So that's why. Again in j cap we are having dz dx j cap, because we know j cap means direction of y axis. So direction of y axis is perpendicular to xz plane. So we write dz dx j cap. Similarly, we are having k cap means direction of z axis. Direction of z axis is perpendicular to which plane? xy plane. So we write dx dy k cap. Now, then we are having the surface integral f vector dot ds vector. When we dot product, we know I dot I1, and when we dot product I with j, k, or j with any other I or k, we get 0. So we will get only I dot I, j dot j plus k dot k. So when we dot product f vector with ds, we get f1 dy dz plus f2 dz dx plus f3 dx dy. In this way, we will find out the surface integral over the surface S when vector point function f is acting upon surface S at point P. Now, this is the application of surface integral. First of all, we are having the flux. What is flux? Flux is the vector quantity. Vector quantity means it represents the magnitude and direction. We know vector quantity means which have magnitude plus direction. And magnitude and direction of what? Flow of substance. When we take any fluid cross over a surface S, then the flow of substance represent the flux. So, if vector function f represent the velocity vector v, means कि ਹੁਣ अपने कोल vector function f आ जो represent करता velocity ਨੂੰ, fluid ਦੀ velocity ਨੂੰ जे vector point function f represent करे, then our surface integral, जे ਆਪਾਂ surface integral लवांगे velocity v ਦਾ over a closed surface ds vector, or we can write as this surface integral of velocity vector v into normal vector into ds, or we can write this as ds whole. When we multiply normal component with small ds element, we get as ds. So when we find out the surface integral of velocity vector over closed surface, we get the rate of flow of fluid. That when we get surface integral of this velocity vector of fluid, then we get the rate of flow of fluid. That what is the rate of flow of fluid across the surface S. Then the rate of flow of the surface, rate of flow of fluid represent what? Flux. So our flux is calculated as surface integral of vector function. If vector function represent velocity, then velocity vector, then we can write like this: double integral velocity vector dot product our ds vector. Next, we are having the volume integral. How we will find volume integral? In this, f is our vector point function and v is volume enclosed by the surface S. So volume integral will be found as triple integral v f vector dv. Now we know dv is equals to s, v is equals to xyz. So our dv is equals to dx, dy and dz. So our f vector is equals to f1 I cap, f2 j cap plus f3 k cap, and dv is equals to dx, dy, dz. Triple integral f dot product dv. So our dv will be multiplied with each. f1 I cap, f1 dx, dy, dz plus j cap, triple integral v, f2 dx, dy, dz plus k cap, triple integral of volume, f3 dx, dy, dz.